Yes, welcome. Let's look at this JAMB question chemistry for 2018, question number 1. The periodic classification of the elements is an arrangement of the elements in order of their A. Atomic weights, B. Isotopic weights, C. Molecular weights, D. Atomic numbers. Now, for us to understand this very well, we need to first of all know what the periodic table is, where we have the periodic classification of the elements. So what is the periodic table? So by definition, the periodic table is the arrangement of elements in order of increasing relative atomic masses or relative atomic mass. That is what the periodic table is. Periodic table is simply the what? Arrangement of elements. You have a table like this, where you have elements arranged in the periodic table. Now, what is actually happening in this periodic table? In this periodic table, the elements with similar properties. In the periodic table, the elements with similar properties they will always keep on recurring at regular intervals. And these regular intervals is called periods. Regular intervals or period. So that is what happens in the periodic table. So you have the periods and the groups. So the periodic table is actually the arrangement in the order of increasing atomic mass. So how do you get the atomic mass? You know that the atomic mass is a function of the atomic numbers. So the atomic mass is a function of the atomic number. So from that, we can easily say that the right answer should be the atomic numbers. D should be the correct answer, because as the atomic number is increasing, the mass number is also increasing. Or the atomic mass is also increasing. So you find out that something that has the atomic number of 6, we have the mass number of atomic mass of 12. One that has 8, we have the number of 16. So you have this type of increment. So actually the periodic table is arrangement due to the atomic numbers, or you call it atomic masses. So that is the correct option, the D. And also, you should know that the periodic table is the arrangement of elements in the order of increasing relative atomic masses. And the elements with similar properties will keep on increasing as regular intervals called periods. Now, it's also important to know that the atomic number is the number of protons in an atom. Whenever you hear the word atomic number, what does it mean? Atomic number is the number of protons in an atom. That is what atomic number is. So when you have an atom, it will have a nucleus, and inside this nucleus you have the protons as well as the neutrons. So the revolving around the nucleus is the electrons. So the number of these protons So something like that. So you have these arrangements in the periodic table is actually according to their atomic numbers. In this case, you have atomic masses. Atomic masses is also a function of the atomic. So it is atomic weight, it is mass, atomic weight, and it is not molecular weight. So the right option is D, atomic numbers. Thank you. Hello, welcome. Let's look at this JAMB past question for chemistry 2018. Question number 2. If 1 liter of 2.2 molar sulfuric acid is poured into a bucket containing 10 liters of water, and the resulting solution mixed thoroughly, the resulting sulfuric acid concentration will be A, 2.2 m, B, 1.1 m, C, 0.22 m, D, 0.11 m. Now, whenever you see a problem that concerns solution formation, solute inside a solvent, whenever it falls solution formation, the general formula that is used is Ca Va, that's concentration of A, that is one of the components, times its volume, all over concentration of the other one times its volume, equal to number of moles of the first one over number of moles of the second one. So this is the formula that you use whenever you see similar calculation to this. Now, what is our Ca in this case? Ca is the concentration of the sulfuric acid, and it's given as 2.2. Now, what is Va in this case? We are taking the acid as A. So volume of the acid in this case is 1 liter. Now, what is Cb? Which is the resulting concentration when it is thoroughly mixed, which we don't actually know. Now, what is Vb? Which is the volume of the water this time around, which is, we are given as 10 liters. So we have 10 liters. Now, what is the number of moles involved? If you write the chemical equation, you will find out that Mb is 1 and Mb is also 1. So having this, if you fix this in this equation, Ca, we already know is 2.2. So we have 2.2 times Va is what? 1. All over Cb is what? Cb we don't know, so we still write Cb times Vb is what? 10, equal to 1 over 1, which is 1. So if you make Cb the subject of the formula, we have Cb equal to, if you cross multiply, you have 2.2 times 1 times 1 all over 10. So this will give us 2.2 over 10, which is 0.22 m. So that is the value of our Cb, and that is C is the right option, 0.22 m. So the most important thing that you need to go away with in this very solution is that once you have something that involves mixing sulfuric acid being poured into water, checking the concentration, you need to use this formula. This is the general formula for calculation. So all this will be given to you. If you want to get this, you can simply write the equation of the reaction so that you see the number of moles. So if you have A reacting with B to 4, so you see that the number Na here is 1, because if it is 1, it's not written. Nb, this Mb here is also 1. Or if you have 2 here, then this thing has to be 1 over 2. If you have 3 here, then it can now be 3 over 2. So it depends on what is in front of this molecule that you call your Na and Mb. So that's how you locate your Na. So that is it for this. Thank you. Hello, welcome. Let's look at this JAMB past question, Chemistry 2018, question number 3. In the above experiments, Fig 1, the litmus paper will initially A. Be placed, B. Turn green, C. Turn red, D. Turn blue. So this is the actual experiment in this Fig 1. This is actually a damp neutral litmus paper. It's placed on top of this tube, and this is a porous asbestos plug. And right inside this tube, we will have solid ammonium chloride, and it is being heated to a temperature of 350 degrees Celsius. So when you heat this ammonium chloride to this very temperature, it will release ammonia gas. So what will ammonia gas do to a damp neutral litmus paper? Ammonia gas, is an alkaline gas, so it will naturally turn the neutral litmus paper to blue. So the actual answer to this problem is that it will turn it to blue. D is the answer. Because why? With the experiment that we are looking at, ammonia gas is going to be formed. And we all know that ammonia gas is an alkaline gas. And what does alkaline do to a litmus paper? It turns red litmus towards blue. So that's what will happen. So that is why D is the answer to this. So in this, we need to know what is going to form. When we look at this sketch very well, we are going to find out that when solid ammonium chloride is heated at this very temperature of 350, ammonia gas that has a characteristic choky smell, which is easily recognizable, is released. So we can actually find this topic under nitrogen and its compound. And you can actually test for ammonia. When you check for test for ammonia, you'll be able to understand this very well. Test for, then you see this. So this topic is under nitrogen and its compounds in your chemistry textbook. So what you're considering here is sodium chloride. So whenever it is heated, ammonia has to be liberated, and this ammonia turns this very litmus paper to blue. And that is why we have this as your answer. So the right answer is turns blue, D. Thank you. Now let's look at this problem for JAMB past question chemistry 2018, question number 4. A correct electrochemical series can be obtained from K, which is potassium, sodium Na, Ca calcium, Al aluminium, Mg magnesium, Zn zinc, Fe iron, Pb lead, Hg, Cu, Hg, Au by interchanging. So what do you interchange in order to make this to be the correct electrochemical series? Now, if you look at the electronic configuration of these various elements, which actually determines their arrangement in the electrochemical series, you will find out that aluminium comes before potassium. So this very Al comes before potassium, which is K, and then magnesium comes before aluminium. So now, let me write the right arrangement that we are supposed to have for the electrochemical series. We're supposed to have H, then Na, then Mg, then Al, then K, then Ca, then Fe, then Cu, then Zn, then Ag, then Au, then Hg, then Bb. So that should be the right arrangement. And now, having this arrangement, you can see that the right interchanging should be A, where you have Mg coming before Al. So we have to interchange this so that we are supposed to have Mg before Al and not the other way. So if you interchange this Al coming before Mg to Mg before Al, then we are going to have the right electrochemical series this time. So you can check this under electrochemical series so that we see this right arrangement. Hello, welcome. Let's look at this JAMB past question, Chemistry 2018, question number 5. A basic postulate of the kinetic theory of gases is that the molecules of a gas move in straight lines between collisions. This implies that A. Collisions are perfectly elastic. B. Forces of repulsion exist. C. Forces of repulsion and attractions are inequilibrium. D. Collisions are inelastic. Now, for us to understand this and be able to answer about the kinetic theory of gases or matter. Now, the kinetic theory of matter or gases actually postulates that these particles, that is the particles of the gases, are continually, if you check the textbook, you're going to find this out, continually moving. The particles of the gases are continually moving, and therefore, so they possess kinetic energy. So that is the postulate. So according to the assumption of kinetic theory of gases, they actually move in a straight line between collisions. The gas molecules will collide with one another and with the walls of the container. So what actually happens is that if you have gas molecules, they are constantly colliding with one another, and they are also colliding with the walls of the container. That's what is happening. That's what the postulate of the kinetic theory of gas says. So they constantly do that. So there is the force of repulsion that exists between them. There is force of repulsion existing. So this force of repulsion also enables this collision with the walls of the container and with them. So if you check out things like the Van der Waals force, the Van der Waals equation for solving gas movement, you're going to find out that there is space for correction due to volume and correction due to force of repulsion A and B. So all this tends to point towards these forces of repulsion exist. Whenever you talk about kinetic theory of gases, you must mention the forces of repulsion that exist between the molecules, which enables pressure to be created due to the collision with the walls of the container. So, if you go by elimination, perfectly elastic is not there. If you check the kinetic theory of gases, that's what we're looking at. So the postulate of kinetic theory of gases particles are continually moving, and so they possess kinetic energy. Now, what actually happens is that the gas molecules will collide with one another. So there is always collision of gas molecules with one another, and also with the of the container. So that's where collision normally happens with one another and with the walls of container. And there is always force of repulsion existing. If you check the Van der Waals equation, you see where this force, where this correction for force of repulsion is taken care of. So B is the accurate answer. But take note of the postulate or the statements of the kinetic theory of gases. That the gas particles are in continual motion, and so they possess kinetic energy. And as they are moving in this very motion, they are colliding with one another and with the walls of the container. Thank you. Hello, now let's look at this question number 6 for JAMB Past Question Chemistry 2018. On which of the following is the solubility of a gaseous substance dependent? I. Nature of solvent. II. Nature of solute. III. Temperature. IV. Pressure. Option II, III, and IV. B. I only. C. II only. D. II, and IV only. So what is the correct answer to this question? Now, for us to fully understand this question and be able to take very good care of it, we need to first of all know the factors that determine the solubility of gases. What are the factors that determine the solubility of gases? So for us to do this, we will need to know the factors that control solubility of gases. Now, when you check through your textbook, you're going to find out that some of these factors are, number one, very, very importantly, for gases, you have pressure. Pressure is a very, very important determinant of the solubility of a gas. Then number two, you have temperature. Temperature determines both the solubility of gas and that of solids, very importantly. Now, very, very importantly, you need to know that the nature of the solvents, like some gases are soluble in water, whereas some are not. So the nature of the solvent is also very, very important. Nature of the solvent. So you have a solvent like water can dissolve HCl. It can also dissolve ammonia. So this one will give us a basic solution. When it dissolves in water, this one will give us an acidic solution, hydrochloric chloride. Give us an acidic solution. So if you have the solvent as water, it will very much affect the solubility of any of these gases. So these are the three major factors that affect the solubility of gases. The solubility of gases is highly dependent on the temperature. The solubility of gases is highly dependent temperature is increasing for gases, the solubility will decrease. Whereas for solid, as the temperature increases, the solubility increases. So these are the three major factors, and from the options you can see that option D takes care of this, because I is nature of solvent, I is temperature, IV is pressure. So these are the three major things that the solubility of gases depend on. So provided you already have a solute, in this case the gas, solubility will now depend on these three other things: nature of solvent, temperature, and pressure. So the right option is D. Thank you. Yes, welcome. Let's look at this question number 7 for JAMB past question chemistry 2018. Which of the following statements is correct about the periodic table? A. Elements in the same period have the same number of valence electrons. B. The valence electrons of the elements in the same period increase progressively across them. C. Elements in the same group number of electron shells. D. The non-metallic properties of the elements tend to decrease across each period. Now, for us to understand this question very well, we need to know what the periodic table is and how it is arranged. Now, we know that the periodic table is the arrangement of elements according to their atomic numbers. And basically, they are arranged into groups of 1, 2, 3, 4, 5, 6, 7, and finally 8, which is actually group O. So that is the groups of the periodic table. Now we have what we call the period. And you actually have periods 1, 2, 3, 4, 5, 6, 7. So you have 8 groups and 7 periods. So that is what we have as the periodic table. Now in this periodic table, we have the arrangement of elements according to their atomic numbers. So that here we have hydrogen. This is how the periodic table looks. This is a rough sketch of what the periodic table is. So you have hydrogen there. Then in period 2 you have lithium and beryllium. Whereas on this other side you have boron, period 3 of period 1 of group 3. Then under group 4 we have carbon, we have nitrogen, we have oxygen, we have fluorine, we have neon. Sorry, this is actually supposed to be in 2. Supposed to be in this period 2 actually. chlorine, and neon. And we're supposed to also have helium here. And in 3, we're supposed to have sodium, magnesium, and on this other side we have aluminium, silicon, phosphorus, sulfur, chlorine, argon. Here we're supposed to have potassium and calcium. So that's about the first 20 elements in the periodic table. So I want you to notice something. This is the groups, group 1, group 2, 3, 4 down. So all the elements in the same group have the same number of valence electrons. So what are the characteristics of the periodic table? Number 1 is that elements in the same group, like this hydrogen, lithium, sodium, and potassium, all of them have the same number of valence electrons. Elements in the same